and play around with our intro system. And well, I want to use this opportunity to encourage you using it, making cool stuff with it. And unfortunately, it is a very complex system. Although there's a very rich documentation supplied with it, some things can be better explained by showing it. As you see, I will do the whole presentation just with the tool and not with an ordinary slideshow. And if you can't read the comments here so clearly because they're too small font, I will tell what I'm saying is much more specific than the comments anyway. If you've ever tried the werkzeug, you might notice that there's a new version out. This is version 1.2.01. And this is mainly a bug fix version. Nothing much. Oh, I have. There hasn't been many changes. It's just crashes which were fixed. And the only really new feature is that if you have a cool texture like this, you can now save it as a bitmap. Because I think the best part of the werkzeug is the texture generator, and it might be useful to just use it to create textures and for use somewhere else. But the texture generator is not the only thing which is there in the werkzeug. The werkzeug can be used to create complete demos. And well, I have prepared a little demo here. It is not really a good demo, it's just one object rotating in the middle of the screen. But it shall serve as an example what you need to create a demo. And as you can see here, a demo consists of textures, materials, meshes, connecting many objects to a scene, and defining the screen layout. And in the werkzeug, everything is done with these little boxes, with the operators. And therefore, there are many, many operators to choose from. You can see here that these are the texture operators, these are the mesh operator, these are material operators, scene graph operators, screen operators, and all the small stuff that doesn't fit into any category. And the first problem people have when they try to make a demo is that all these different kinds, these different classes of operators have to be combined in the correct way. And there's actually one correct way to connect them, and if you use something different, it simply won't work. Everything usually starts with textures. I have here 2 textures. And then you can use up to 2 textures to define a material. The material tells how the object is shaded and how light is applied and how the textures are combined. The next thing you have is a mesh. This is all the vertices, edges, and faces are defined. And of course, you will want to apply a material to the mesh so that you can see the textures on it. If you're doing a real demo, you will need many, many objects which are combined to a scene. In this case, the scene is a very simple thing because there is only one object, so there's nothing to combine or move around, to be moved around. And the last big thing for a demo is to define how it is on the screen. We have a camera operator where we can have the camera settings, and then we have the FX chain, which makes the glare look. Well, and the last thing you need is to put multiple screens together to define things on the timeline, which is mainly done with the time operator and the demo operator. And here I added a metronome. Usually we will be adding real music to it, and there's an end operator. You see, the operators are color-coded. And each color is for a certain kind, and the remaining here are the unimportant operators that don't deserve their own color. But we have what color is this anyway? Cyan, texture operator, green material operators, pink mesh operators, yellow scene operators, and orange screen operators. And whenever you're trying to build something in the werkzeug, you will most likely follow this layout. In a real demo, as you can see in our example file, FAO25, you will have many, many pages of operators, thousands of operators, whole pages only for textures, whole pages only for a very huge demo operator that connects everything together. But still, it will always be this layout. One special notion has to be the difference between these two operators. There we have a pink operator, which transforms meshes, and we have a yellow operator, which transforms scene. They actually do almost the same. I can just move around objects with it. Whoops, wrong button. And here also just move around objects. The difference is when I transform a mesh, when I use the pink operator, I will be changing the position of every single vertex. This object has 6,000 vertices, and you can imagine if you're moving around things a lot, this will take some time. You don't want to move around an object every frame. If I move around the scene, I will only paint the object at a different place. This just goes for free. I don't have to pay any processing time for that. And if you notice me here, I have here 50 FPS for the simple scene. If I change something here in the transform operator, the frame rate won't really drop. And if I change something here at the transform mesh operator, the frame rate will collapse. So if you're trying to animate the movements, you should better use the scene, the yellow transform, and not the pink transform. You actually have to take care for this transition from pink to yellow. When you're modeling, creating stuff, you will be using mesh operators. And then there will be a point when you turn the mesh into a scene. And after you've turned the mesh into a scene, you will never go back to mesh. This is a step you go. After that, you have a mesh. As I said, this order will be always the same. You will start with the mesh, then comes the scene, and then comes the camera. There are certain operators which allow you to change the class. You see the texture operators. I built here a texture, very, very simple way of building a texture. They just stick with each other. I need the material operator, which inputs a texture to turn a texture into a material. And I use this material input operator to input a mesh and a material, and to output a mesh with the material applied. So you have always to care that you connect the operators correctly. If I would put the texture into the material, just as it is, it doesn't work. Actually, a red line should appear here, which it doesn't at the moment. Why? I don't know why. Usually, if you connect something incorrectly, you will always get red lines. This just means I can't stack the operators like this. I can't take a cube and apply a rectangular texture to it. It won't work. Keeping this in mind, organizing your scene with the werkzeug is a pretty simple thing. You just have to know what you're doing. People who tried the werkzeug out at the beginning wanted to have a texture on screen, just display a picture. And even for just displaying a picture, you will have to follow the path. So what I have here is I made a simple texture, created a material, where I have all the great material options, which I will be explaining later, for doing blend modes and stuff. Well, I could now apply the texture to a cube and place the cube in front of the camera. Fortunately, there's a simpler way. I have the layer 2D operator, which does exactly that. It puts the texture in front of the camera. And well, then I have the usual stuff here. Camera and some demo and animation and so on. The good thing about the layer 2D animation operator is that I can just multiply the texture, position the texture, scroll it, and I can fade it. Actually, the easiest way to fade something in and out is use the layer 2D operator. And whenever you want to have simple fade in, fade out, it's usually a layer 2D you're using. And again, I have to connect these operators into the right order, and everything will be fine. So much about the basic construction of demos with the werkzeug. this system is very structured, I think, and once you get used to it, you will have no problem with it. Another system which is very important in the werkzeug is animation. And that's unfortunately not very structured, and you will never like it. But it works, and you can do some nice stuff with it, and some things even work great, but not everything. The first level of confusion I built into the werkzeug is the metrics for time. The time metrics work, you see here a time counter running. There are 256 fractions, which make up 1 beat, and 4 beats make up 1 bar. This is simply assuming that everyone uses 4 quarter beats, which is true for all my demos except one. Where's Melvin? What rhythm did you use for time index?
I think it was something like
19 quarters. Well, that really spoils the system. It made things a little bit complicated to time. But with this fixed choice of having 4 quarter beats, well, most of the time it really works. So we have these bars, beats, and fractions. And if you see a timeline here, you see these bars are actually bars. Even the big bars are just bars. And we have another timeline here where we can place things in the timeline, and these metrics are also in bars. But if we have a time operator, this is a fraction. So actually, this whole thing is 16 bars, and this is why there's 64 fractions. So just keep that in mind. And in the metronome, you can tell how long the demo is. This is mainly used to scale the timeline below there. This is bars again. And to make things even complicated, in the version of the werkzeug before, here was the wrong name. It was beats, but it is bars. So keep in mind, sometimes it's bars, sometimes it's beats. Most of the cases, you will know what it is. Just don't get confused. And there's even another level of confusion. First, I want to tell, as you see, everything is done with operators. Even the timeline is done with operators. I have here a time operator. And I have here a timeline. And I can edit this in the timeline. But the timeline is nothing new. It's just another way of viewing the operators. If I change the position in the timeline, or if I change the position here and directly in the operator, it's absolutely the same. But of course, if you have 100 time operators, you want to have a clear view to all your times. And therefore, we have this different way of viewing the time operators, the timeline. It's very handy to control your demo. And you see, I can move it around here. Can move it by 3 beats. And then I can make some fine-tuning here. And I can move it by 3 beats and 256 fractions, which is actually 4 beats. But I can move it even further here. And this is a little bit confusing that you can move this value up to 1024, which would be 4 beats. Although this measure is in beats. But it is a very useful thing that this goes over the 225. Although it is a little bit confusing. So, time units. I have made a little bit more complicated demo here. It features 2 objects, not just one. And this is the basic use of the time operator, is that you can place things in the timeline. You see it here. We have the effect 1 and the effect 2. And only when the time is in this range, everything above the time operator is drawn, is executed. This is your basic means to place things in the timeline. Just put a time operator somewhere, then it appears in the timeline, and move it around. You can place time operators almost everywhere. As I said, there's a very strict order. You have, as you can see here, again, you have the mesh, then the transform, there's the scene, and then the camera. But the time operator can be placed everywhere. Whatever goes in goes out. You can place it directly in the scene, or below the camera, or above the camera, or wherever you want. The time operator does two things. The first thing, I already told you, you can place things in the timeline with the time operator. And the second thing is, during the time that passes from the begin to the end, it animates an internal variable, which is called channel 0, from 0 to 1. As you can see here, here is this number which is animated. Bad example. Let's take this number from 0 to 1 as the time moves here in the timeline. We have 1, we have 0. And I can just press the animation button here and say him animate on. I want to take channel 0 and put it on the y-axis. I don't want to amplify it. I could amplify it a bit, then things rotate a lot faster, maybe a lot too fast, or in the other direction. And I can set a start value, just move it around so it doesn't always start with 0. And I can use this to make very simple linear animations. If I just want something to rotate, well, I simply take a time operator, use channel 0, and it will rotate or move in a linear fashion. When we were building this, we thought that you really have to save memory, because we're going to do intros, 64K intros, and a spline always takes a lot of memory. But if we do most animation doesn't really require a spline, and the ability to do linear animations just by a few clicks is quite handy, and it saves memory. When you're trying to do really good animation, you won't get far with linear movements. You will need more. And well, I said the time operator animates channel 0, and you can use channel 0 for animation. This almost implies that there's more than channel 0, that there's channel 1, 2, 3, and 255. Here I have a more complicated example with 3 other animation primitives. That you can use to make simple algorithmic patterns of movement. Let's first concentrate on this example. This is an obvious idea that if you have a channel 0 and want to animate something with it, then you might want to have a sinus movement, not just moving from start to the end, but a sinus movement. And there are actually other shapes to set. We have a triangular movement, which will be not so smooth as a sine. We have a ramp up, which will always move up. And we have the ramp down. We also have the rectangular movement, which is on, off. And there's even the flat movement, which is always on, in case you need some strange things to do. So if you just want something to shake, or something to move in a simple way, this is much better than to create a spline which has a sinus movement. This will always look bad, and it's a lot of work and will cost a lot of storage. And for many movements, the simple things will be enough. You can also say the repeat value, you can move it faster, and you can move it slower. You can amplify the movements. Actually, you can amplify it in 2 places. It's the same as you already had in the other button. And you can offset it. And yeah, well, the most important thing is this operator takes channel 0, applies the function like sine, outputs it to channel 1, or whatever I want. And then I can use channel 1 to animate the Y position. And I also use here channel 0 to animate the rotation. It's rotating slowly, as you can see here. Well, we had this shaking, and it is actually a useful feature to be able to fade in or fade out this shaking. So there's one more complex version of this effect. you can see this one shaking and fading in and out. This is this is not. This is the double mode. We have the sine movement we had before. We can also use the ramp up movement or the ramp down or whatever. Sine is most pretty for this example. And then we have a slower movement. This is actually only half a sine, which fades on and off in a very smooth fashion. We have the triangle version, which is less smooth, but the difference isn't so obvious. The ramp up, which will just fade in the movement, or the ramp down, which fades it out. So we can build more complex, still very mathematical movements. Well, the first version I showed you, the sines, is a very useful feature. The second is not that useful. There might be places where it is very comfortable, but well, it's not actually a main feature of this tool. A real main feature is the beat patterns. This is the third way to do simple animations, also with a channel animation operator. What I have here is just ramp down, a very tiny movement of ramp down, and here I have a beat pattern. I can just type in some numbers, and if there's a 1, the movement will happen, and if there's a 0, the movement will be omitted. So if I make this, you see how he's missing all the movements. And if I not type in a 1, but a larger number like a 4, the animation will be, in this case, 4 times larger. And so you can create complex patterns, maybe in sync to the music, just by putting in some numbers here. This is a very limited way of doing animation, but if this is what you want, if this is all you need, it can be a very efficient way to create animation. You can use, for instance, the beat pattern to place events. But unfortunately, you're not likely to build your camera movements just by adding sines and cosines. That will always look extraordinarily ugly. Therefore, there was no way getting around to add spline support for the werkzeug. And this actually is the worst spot of the werkzeug. The spline editor is everything but pretty. It's there, sometimes it works, but you will not like it. Still, I have to show it to you, because it's of course important, especially for camera movements. There's no way getting around editing splines. I already told, everything in the werkzeug is done with operators. And even the spline, which is here connected, is built out of operators. We have key operators, and we have the spline operator, which combines the keys to the spline. But fortunately, you don't have to ever place a single spline or key operator to do this. There is some user interface built around it, and the werkzeug will create all the operators you need automatically. And it all starts, I have to remove the spline, which is already here, because otherwise it doesn't start. It all starts with when you have a camera operator with no spline attached. Click on it and go to the spline editor. You will see that the spline is automatically created and added to the spline editor. I have a very basic spline here with 2 keys. I think I should add a 3rd key. And I missed one point. I have to go back, remove the spline. The first problem we will have with cameras is you will be used to be able to move around your scene with some keys, like P for moving forward or backward, O for orbit around, and Z for all other kinds of movements. But if you have a camera in your scene, this won't work. You can't use these keys anymore. You have to change, now it's working, the parameters over here. And that is bad. It will be very hard to find the right angle if you just have to drag numbers. That's why there is a link edit. You press the key L, and then your usual camera dragging operation will be automatically translated to these values. This is, of course, an absolute necessity to make a good camera. But on the other hand, it imposes the danger that when you accidentally move your scene, that you change the camera. So be careful that you switch off link edit when you're done. Otherwise, you are in danger of destroying your cameras. And now if I add a spline, as I said, I click here and go to the spline editor. I wanted to have one more key. And now I have to go to link edit, otherwise it won't work. And I can move the camera to places which I assume are nice. Well, fortunately, I'm not a graphic, so it doesn't need to be really nice. Just imagine something. And so I can come here up with a spline, add more keys to, oops, click. You are actually not supposed to really click on such a box and drag on it. Most likely you will pick the wrong box. It is much simpler to click here on the parameters to change the values. And otherwise use these keys to do the animation. And now if I go out of the spline editor, I assume we have another ugly camera movement. It's not a really good spline editor, but you can get the job done with it. And there's one thing. There are only two things you can animate with splines. That is the camera and scenes. You cannot just take a spline to animate a color or something. Very unfortunate limitation. But you can use the apply spline operator, as I have done to this strange thing, to apply a spline to an object in a scene and move it around. Wrong key. Right key. And then it will make that changed movement. So much for the spline editor. As I said, this is a really ugly part, and I don't like it a lot, but if I want that anybody is able to use the werkzeug, then I have to talk about it, because animation is pretty important for demos. I'm happy that I can now go to a part which works very good, the material system. So that makes me a lot happy we are explaining things that work. You might have seen the talk from Fiverr and Gizmo, where they have been showing the material operator that is used for Krieger. The material Krieger had support for pixel shaders. And this is a material operator used for non-pixel shaders. Actually, there's pixel shader support in werkkzeug1 too, but that is much simpler. And I'm now talking only about the non-pixel shader, the simple material operator. And, well, it is a lot better. We have here some general operators. This is what I'll be talking, some general flags. This is what I'll be talking most. And then we have two textures, which you can switch on filtering and tiling and whatever you want. And this is all you need. There are also stencil options, but they are more experimental. And you can do some fog options, which are pretty nice. But actually all you need for the material is this. This is a limited selection of the most useful options you have in DirectX. The first thing, I made this cube translucent, and you see that everything is double-sided. You see the front faces and the back faces. This is not normal. Normally, graphic cards will only paint the front faces. And since you can't usually look through objects, the back faces can be omitted, and everything will be simply faster. The graphic card saves painting more than half of the faces, just by painting only the front facing. But with this button, you can switch off this behavior, and you have the double-sided look. There's one big problem with transparent faces. The Z buffer doesn't work for them. So if I would have the Z buffer on, which is default of course, strange things happen. A solution would be to switch the Z buffer off. Then everything is fine, but then this object wouldn't interact with everything else on the board. A compromise is to switch it to read only. This works fine for the transparent object, and the object will still work correctly with opaque scene, with the rest. You simply have to make sure that all the opaque scenery is painted first, and then the transparent polygons are painted with this Z buffer setting on top of it. To sort things into the right order, we have this path. You don't have to shuffle things in the timeline or shuffle things in the operator tree. The 3D engine we have will sort everything by path. So if you assign a high path to it, you can be sure that it will be drawn very late. So whenever you have transparent stuff, assign a high path to it. Once you see mistakes, set problems. And if you have multiple transparencies and want to have them applied in the correct order, make sure that the passes are in the correct order. Most of the time, everything will work very well. But if you're using a lot of alpha blending, you might need some very carefully chosen drawing order to get the right result. The 3D engine will not sort automatically. You have to sort the passes yourself. Well, okay, I have here this cube. I just want to make it single-sided again, and this will be most interesting for the graphicians among you. The coders will most likely know all the possibilities. I want more cubes. Well, that's enough cubes. What I'm doing here is I use translucent polygons. In this case, I use additive translucent polygons. Instead of, when I draw a pixel, or when the graphics card draws a pixel, instead of replacing the background, it adds to the background. You will start having to see colors as numbers. Black is 0, and white is 1. And if you add things, and if you add only positive numbers, and colors are always positive, things will get brighter and brighter. And so you can use additive shading to make things brighter. Things will start getting white very soon. It will be clamped at white. This is the problem of additive shade blending. It sooner or later will become all white. There's one option here. Here you can select the blend mode. There are quite many blend modes. Additive is the most important. Smooth, or add smooth, is another option. It works almost like additive, but it approaches white in a much more gentle fashion. You see, there's more contrast in the way this gets white. If I switch to add, it will be all white. If I switch to smooth, it will approach white in a smoother way. Of course, there's a difference. I said add will always make things brighter. The opposite would be to multiply. If I switch the blend mode to multiplication, I can work myself from white to black. With additive, I can work from black to white. With multiplication, I can work from white to black. This is simply the colors are interpreted to be in the range from 0 to 1. And if I multiply something with a value lower than 1, it will always get lower. Definitely ending with black. You see, I'm all the time I'm changing the colors just to make to show the effect, because they all require different colors to be really visible. You could now, if you want to add many layers, use add and mul alternately to so that you never reach white or black, but to stay in the middle where no information gets lost. One very interesting blend mode is multiply by 2. With this blend mode, the color is interpreted to be in the range from 0 to 2. That means you can multiply with values lower than 1, making things darker, and with values higher than 1, making things brighter. Like I can show here. This, you can go darker and brighter. This can be very useful. If you just want to make subtle changes into two directions, use a gray texture, and which has some parts which are brighter than middle gray and some parts which are darker than middle gray. Well, the most basic blend mode is, of course, alpha blending. This texture also has an alpha channel. I have to change the parameters again to make the effect most visible. And, well, this is a little bit bad to see. It's a bad texture for this effect. But maybe you can see on the screen that it seems to have holes in it. The problem with alpha blending is that it is not sort order independent. If I have additive blending or multiplicative blending, it is no difference in which order I draw the polygons. A times B or A plus B is the same as B times A or B plus A. With alpha blending, this is not the case. This effect works if I paint the polygons in one direction, but it doesn't work if I paint the polygons in the other direction. This is a very bad property of alpha blending, which is a reason for many, many problems. Render passes, the passes you can select here will reduce the problems, but the basic problem is still there. If I can now change to additive blending, you will see that this is sort order independent. The effect is the same no matter in which direction I make it, which is very good, especially for particles where you have absolutely no control over how they are sorted. Blending is a very powerful tool to make things look nice. Another very powerful tool to make things look nice is environment mapping. With environment mapping, normally the texture is fixed to the object. With environment mapping, you can make the texture flow over the object. There are two versions of environment mapping here, normal environment mapping and spectral environment mapping, which have a slightly different look. And here's one unfortunate problem with the werkzeug. If you have, for instance, a texture like this, simple glow, and use it as an environment map, you would imagine or expect it to look like this, some kind of fake font. Unfortunately, this is not what you will be getting. You will be getting this. The texture is placed in the wrong way. You will need to use the key operator to apply a scaling at the translation so that it is at the right position. You can now see, you can scale the texture, and I can translate it. I should have changed this, but I didn't want it to change this because I didn't want all old demos not to work anymore. Well, now it is too late. I can't change it anymore. But the good thing about it is that you can animate this key to get to apply animation to the texture and to move it around during the demo. Having just one environment map is not really cool. It is much better to be able to use two textures at the same time. And this is exactly what the werkzeug supports usually. With the material operator, you can add two textures. And usually we'll have the first texture to be a static texture like this, and the second texture to be an environment map like this. And now you must be careful again. You can tell with the mode how the two textures are combined. The most useful mode is to just simply add them, but you could also say let's multiply them or subtract one from each other, or many other choices which are less useful. But you see, be careful. This mode parameter chooses how two textures are combined, while the blending operator chooses how the polygon is blended with the background. The options are very similar. You will see here mul and add in both options, but they have different meanings. Yes. And I think this is the last thing I have prepared for this. So you can now ask questions about the werkzeug, and I might be able to answer them. So is there any question? There's a question, very good.
I have a question. Can you go to the last page?
Yes.
The NV key is not connected to the...
Yes. The NV key is linked. There are two basic ways of combining operators. The first thing is stack them over each other. But sometimes you see this, for instance, this material input operator takes one input as a mesh and one input as a material and makes a mesh plus this material applied. So this operator has two inputs. It's always clear the left one is a mesh, the right one is a material. No problem here. But sometimes the order of the inputs isn't enough to determine how things should be stacked. And then I use the method of linking something into an operator. Then I can just choose the name of the operator and link it into it. This allows me to make much more complicated connections than simple operator stacking. Actually, it overcomes the principal backdraw of the operator stacking. The advantage is that I don't have 1,000 arrows pointing to 1,000 objects. The disadvantage is that every connection must be clear and obvious because I don't have named inputs on this operator. Usually, with operator stacking, I will get a perfect solution for 95% of all connections, and the other 5% of the connection must be made in such a strange way. Any other questions? Yes?
How many lines of code?
Pardon? How many lines of code?
Yes.
I have no idea. I don't count my lines of code. It would make me mad. The last time I checked the Krieger source, it was something about 2 megabytes. But werkkzeug is most obviously a little bit smaller. But it's quite a lot, I think.
If there's no more questions, we are going to end here, and let's give a big hand for him.